Hey y'all, Mary Kennedy here. Just trying to get my screen situated. There we go. And we are going to look at figuring out if a sequence is geometric or not today. This is a real straightforward process. I'm going to walk you right through it. Go ahead and hit subscribe because I am going to help you make sense of algebra so that you can learn it and move on with your life. That's what we want to do. We want to get back to the fun stuff on YouTube, right? Okay. So be sure to stick around to the end. I'm going to give you a few extra tips and, something to kind of look for that can kind of help you to know right away if you are seeing something that's not a geometric sequence. All right. So let's take a look at the first one. And the key with geometric sequences is that you're always going to take your second term and divide it by your first term. All right. So second term, first term, literally the first, second, third, fourth. I mean, that's the nice thing about sequences is you're looking at 1, 2, 3, 4, whatever is given to you there. Another thing I want you to notice is the directions say state if each sequence is geometric. It's telling you it's a sequence. We just don't know if it's geometric, arithmetic, some other kind of sequence. Like, we just don't know. So that's all we have to decide is a yes or no kind of thing. So take your second term, which is 101, and divide it by the first term and see what you get. And so you can do 101 divided by 11. But you can also hit this little red toggle button, which is great, and it gives it to you as a fraction, or you could have just typed it in as a fraction to begin with. It doesn't matter. It's all going to give you the same answer. And you just need to get an answer here so that you can go to this next step, which is to take the third term and divide it by the second term. So the third term, 1, 2, 3, is 1001, 1001, divided by the second term, 101. And so now we're going to do the same thing we just did. It doesn't matter if we do it as divide or as a fraction. And now you're comparing. Look and see, is that the same thing? Neither one of these reduced. So they're exactly the way that you wrote them on your paper. And so you can see that those are not the same. If they're not the same, then no, this is not a geometric sequence. Geometric sequences are made of numbers that when you multiply by the same thing, you get the next number, the next term in the sequence every single time. So if this was geometric, then we should be able to multiply by that common ratio, that number that we got as our answer here. And we should be able to get the next term in the sequence and then multiply by that again and get the next term and the next term and so on. And if that doesn't happen, it's not geometric. It may be some other kind of sequence, but it's not a geometric sequence. All right. Let's take a look at the next one. So we're going to do second divided by the first, as always. So the second term here is 9, and the first term is a -3. So 9 divided by -3 is -3. All right. It doesn't matter what your answer is. It matters that you compare your two answers. So third term divided by the second. Third is -27. The second is a 9. And negative divided by positive is -3. All right, those are the same. Now, if you know that your teacher can be very tricky about things, then you need to go ahead and divide 81 by -27 and make sure it's -3. Like, you need to keep going. Typically, though, if you already know it's a sequence, you're just trying to determine geometric. If you get the same thing the first 2 times, you're probably good to go. So this is a yes. If it had asked us to name the common ratio would be -3. Okay. So for those of you that stuck around, I promised that I would show you something else. Let's scroll up here. Let's look at these two. Now, one of the things that you can know about a geometric sequence is if there are negatives and positives in there, they should alternate, or there's no way it's a geometric sequence. So when you look at these two examples, let's call this example 3 and example 4. Okay. So one of them alternates between positives and negatives, and one of them doesn't. It's not consistent. Good. All right. I feel like Blue's Clues just then. That was stupid. Okay. So this one is going back and forth. Example 3 is so positive, negative, positive, negative. And so that doesn't mean it's a geometric sequence. Don't misunderstand me. That just means it could be. But we know automatically that example 4 is not because it's positive, negative, negative, negative. If you're multiplying by the same thing every time, then that sign is going to change every time if it has negatives in it. If it's positives and you've got a ratio that's positive, you're not going to get negatives in there, but it should be positive, negative, or negative, positive, that kind of thing. Okay. So that's a nice little trick to know. So I automatically know that this is a no, to be honest with you, because of the signs. And you could write that as a statement, but if your teacher needs to see the work, then the work is just super straightforward. Second divided by the first, -6 divided by 3 is -2. And then the third divided by the second, -15 over -6. Well, negative divided by negative is a positive, and that'll reduce by 3 to what? 5 over 2. Yep. And so that is not the same. So not a sequence. All right, over here, let's do it again. Second divided by the first term. So -6 divided by 2 is -3. Third term divided by the second, positive 18 over second term is -6, -3. Yes. So we knew it could be because the signs were correct. The signs were good, so we could go ahead and check it out. But that didn't automatically mean that it would be geometric, but it turns out that it is. So I hope that has cleared things up for you. I'll see you next time.